Good morning. Happy Monday. Victory Monday as I'm recording this as the Browns won last night, so going to be a good day. Okay, so we're in the last section here, logarithms, and we're going to talk about solving logarithms and exponentials. So this is really the whole reason, one of the biggest reasons we have logarithms is when we were solving equations, we always have inverse properties to get the x and the variable by itself. Well, that's what logarithms and exponentials allow us to do. So we're going to start off with a really simple type of problem, and then we're going to go from there and kind of work our way to a little bit more difficult. But I'm going to break this down into exponentials and logarithms. As you can see from these first three examples, exponentials are when the variable is in the exponent. So for us to solve for x, we have to be able to bring this variable down. So like I said, we're going to start off simple problems. And this one is really simple. If you've got two exponentials with an equal sign in between it, and you have the bases the same, so this 7 and this 7 are the same, I can literally ignore the 7s, the bases, and just put the exponentials and set them equal to each other and then solve. So this becomes a problem like we solved back at the very beginning of class. We just take the exponents, set them equal to each other, and solve. So I'm going to subtract 5 from both sides. That gives me 2x equals 10. I'm going to divide both sides by 2, and I get x is equal to 5. If you were to go and plug this in, you would see that you would get an equivalent statement. Again, equal sign meaning left equals the right. So I would have 2 times 5 is 10. 10 plus 5 is 15. 7 to the 15th is going to equal 7 to the 15th. So now you see a problem here where you don't have the same basis. So we have to do a little bit of stuff to make these the same bases. And we've got to think about different ways that I can write each one of these bases so that they would be equal. So I could write 2 to the second power instead of writing the number 4, right? And the 3x would stay there. So now I have a power of a power. And same thing here. I could write this as 2 to the third power as x plus 1. So now I've got 2 to the 6x, using my exponent rules, is equal to 2 to the 3x plus 3. Okay, now that I have the same base, I can set these equal to each other, and I have 6x is equal to 3x plus 3. Now I've got to get the x by itself, so back to simple what we did at the very beginning of the year. We're going to move the 3x. I've got 3x equals 3. I divide by 3, and I get x is equal to 1. So again, in going through this, you've got to look at the bases. If they're already the same, like this first example, easy, easy, easy. If they're not, we've got to ask ourselves, is this a perfect square, perfect cube, for perfect fourth power? And you can go back and look at, I believe it was our 6.2 notes where I handed out that power sheet to rewrite these. So 27 can be written as 3 to the third power to the x plus 4 is equal to 3 to the 2x plus 5. So this would be 3 to the, distribute, 3x plus 12 is equal to 3 to the 2x plus 5. So again, I can drop the bases, okay, and I just put 3x plus 12 is equal to 2x plus 5. Equal signs are looking terrible. So I get the x's on one side. I'm going to kind of do 2 steps here. And I would get x is equal to negative 7. And if you plug in negative 7, I would get 27 to the negative third. Plug in negative 7. That would give me 3 to the negative 9th. And when you do the math, the left side would equal the right side. So let's look at a couple problems where we can't make, these still can. So again, same thing here. I'm not going to get into doing a ton of these. I can, but this is 3 to the 3x plus 5 is equal to 3 squared to the x minus 3. So it'd be 3 to the 3x plus 5 is equal to 3 to the 2x minus 6 when I distribute this. And now that I got the bases the same, it'd be 3x plus 5 is equal to 2x minus 6. Now I get the variables on the same side, the numbers, and I get x is equal to negative 11. So as we're doing these problems, again, ask yourself, can I get the bases the same? So you will recognize this, 256 and 16, and if I take the square root of 256, what do I get? 256. The reason I'm taking the square root is because I could get 16 squared, right? So I would write this as 16 squared to the negative first is equal to 16 to the 2x minus 2. And now I would set negative 2 equal to 2x minus 2. I would add 2. 0 is equal to 2x. Divide by 2, and you get x is equal to 0. So we're going to get a numeric answer for these types of problems. Let's move on to some where we can't get the bases the same. So start off again, very simple. What we want to do is we want to get the exponential by itself. So whatever base has the exponent as a variable, that's what needs to be by itself. And then we're going to use logs on both sides. So if I've got 2 to the x, and the way that we do this is we log both sides using the same base, big time calculator. So whatever the base is that has this exponential, I'm going to write log base 2 of 2 to the x. Algebra, we're going to keep it balanced, so I'm going to write log base 2 of 7. Well, if we go back to 7.3, this right here was one of our rules. When I have log base 2 of 2 to the x, the log base 2 of 2 just cancels. Again, this is an exponent. Let me write that a little bit neater, just so I can explain this using our properties. This isn't 2x, it's 2 to the x. So this is 2 to the x power. Well, what do we do with exponents in our rules here? Remember, we take this and put it to the front. So it'd be x log base 2 of 2 equals log base 2 of 7. Well, log base 2 of 2 is 1. So this is how we get the variable by itself. So it'd be x equals log base 2 of 7. And then this right here, we just enter into our calculator. And again, how do we do that? We can use the log button. The base always goes on the bottom. So this base is log base 2. So it'd be log of 7 divided by log of 2 from last section right here. So 2 points. So the answer, make sure you pay attention to Desmos because it is going to ask you to round like to the nearest hundredth. So this would be 2.81. And 81 because this 7 rounds up this 0. Okay, so we try this. So this side, we're not going to log both sides base 2. We're going to log both sides base 4. So I would go log base 4 of 4 to the x is equal to log base 4 of 15. And again, we know that this just cancels out and the x would move to the front. So I've got x is equal to log base 4 of 15. And I would go, again, you can use the natural log of 15 divided by the natural log of 4. And that's just using the change of base from last section. Again, you could have done use this button, log of 15 divided by log of 4. I'm just showing you that it doesn't matter which button you use in the calculator. You can use the natural log or you can use just the regular log base 10 button when you're solving these. So let's move on to a couple more difficult problems. So you can't take the log apart. So we have to get what's being raised to the variable exponent by itself first. So as you can see this 10 to the 2x minus 3 has the variable. So I'm going to subtract this 4 first. And it would be 10 to the 2x minus 3 is equal to 17. And now I'm going to log both sides base 10 of 10 to the 2x minus 3 log of 17. Now, why don't I have a base 10 here? Remember, that's the common logarithm. That's actually what's in our calculator right here. So what happens when I do this is this log base 10 of 10 cancels. I got a 2x minus 3. Notice I had to bring the entire variable down, okay, is equal to log of 17. And then now how would I get x by itself? I would add 3, okay, and I would have 2x is equal to log 17 plus 3 all over I would divide by 2 all over 2. So this is what I'm going to enter into my calculator. And you got to be very careful when you enter this stuff in the calculator. I can't add 17 and 3 and put 20 and then divide by 2 and put 10. I have to get log of 17 as its own number. So I get log 17 equals. Okay, I just like to hit the equals button. What am I going to do next? I'm going to add the 3 plus 3. I'm going to hit equals, and then I'm going to divide that by 2. And again, you might be able to just enter that all into your calculator. That's fine. But you get x is equal to 2.12, again, round in the nearest hundredths place. Got to know how to do that. So in this problem right here, we take a look at it. We would need to add 3 to both sides. So I would get 6 to the x is equal to 13. So now I'm not just going to write log. I'm going to write log base 6. What's being raised to the variable exponent? That's 6. So I write log base 6 of 6 to the x is equal to log base 6 of 13. Okay, well, what happens? If this whole thing cancels, I am left with just an x because x isn't being added or subtracted anything like it is up here. And I get x is equal to log base 6 of 13. I just enter that into the calculator. Log of, again, using the change of base, 13 divided by log of 6. Base always goes on the bottom when you're doing this. So the base always goes on the bottom of the fraction. Hit equals, and you get x is equal to 1.43. Okay. Going to need a calculator. If you don't have a calculator, look one up on the internet. Again, we use that Papa Math one. That will definitely work. So I got 2 more examples here. 2 more examples here, and then we're going to shut this video off and then do the logarithm one. So here we're going to subtract 3 from both sides. So you got 5 to the x plus 2 is equal to 22. So now that I have what's being raised to the variable exponent by itself, I can log both sides base 5. So log base 5 of 5 to the x plus 2 is equal to log base 5 of 22. And again, this is just a number, right? If we went back to the very beginning of this, this means 5 to some power equals 22. We're trying to find that variable. Okay, and notice it's a decimal because we know 5 squared is 25, so it's going to be 1.7 or 1.8, big long decimals. Okay, over here, what happens is that cancels. I bring this to the front, and it gives me x plus 2 is equal to log base 5 of 22. Then we want to get x by itself, so I'm going to subtract the 2, and you get x is equal to log base 5, 22 minus 2. Just enter that in the calculator, and again, hopefully your calculators are updated. I need to update mine, but you can just enter that in there. When you hit the log button, it'll show. But this one, I have to go log of 22 using the change of base divided by log of 5. And again, that's just this number right here. I would hit equals, and then I would subtract the 2, and I would get x is equal to negative 0. I'm going to round this up to an 8, so 0.8, and that would be my answer there. Okay, just rounding. So same thing for this problem. We're going to add 5. 7 to the x plus 3 is equal to 13. Now I'm going to log both sides base 7 to the x plus 3, log base 7 of 13. And again, where am I getting the 7 from? It's whatever's being raised to the variable exponent. So that cancels, comes down in front. X plus 3 is equal to log base 7 of 13. I'm going to subtract the 3. X is equal to log base 7 of 13 minus 3, and know that this is its own number. So I've got to do that first. Again, your calculator is going to be your best friend here. Divided by log of 7. That's 1.3182, and then I'm going to subtract 3 from that. And I get x is equal to negative 1.68. So there's going to be some problems like this. Give it a shot. The second part I'm going to make a separate video for because that's solving logarithms. They look a little bit different. But again, happy Victory Monday. Make sure you're watching the videos, taking notes, and we will be having a quiz tomorrow.